Good morning everyone, it's Thursday the 30th of April. On Tuesday I had a phone call from a gentleman called Paul Hope, the Engineering Support Manager at North East Truck and Van in the northeast of England in the UK. It's a large company, they've got quite a lot of branches in the northeast, and they predominantly do lorries and commercial vans. They are the UK, or one of the two UK distributors for Telma parts. I'd sent an email to Telma in France last week asking basically for a price and a UK distributor where I could buy a replacement coil. They forwarded my email to Paul and he phoned me up on Tuesday and said, I've got a couple of second-hand coils, would you like them? And that one with the blue tape on it, that tape's only to hold the gasket on because they're a bit fragile. I've just fitted that. He actually sent me two. There's the other one there. It's in a little bit worse condition. One of the green plastic straps has snapped, so I'll use that as a spare. But he sent me two. He didn't even charge me for them. I will be paying for these, but he sent them completely free of charge, just so I could check whether they work or not. So I've just wired this one in. Fortunately, there was enough tiles left on the cable harness that I didn't have to crimp up the aluminium windings, and I've just made crimp joints on the existing white cables. And then I've used, and it's quite important to think about this, there's a lot of water gets in these devices, so I've used glue lined heat shrink tubing on the two joints I've made to make sure there's no water ingress. They've done the same on the crimps that go from the aluminium windings of the coils to the copper cables as well. Because you get any water in those, you're going to get whatever the term is, where you get a reaction between two different metals. I actually had to unwind my 40 coil to recover the core because it was rusted, really rusted in. I did actually find the break almost dead centre in the original coil, and as I said, thanks to Paul Hope, I'm in business. The coil winding is exactly the same. I don't see any reason it won't work now, but there it is there. I didn't have any black silicone, so I've just used white just to pot it in. That's really just to stop the coil moving around on the core. Obviously the other coils, they're all rusted onto their cores, they're not going anywhere, but this one is a loose fit, and by default when they're built in the factory they obviously pot these down just to prevent any unnecessary movement. The other thing that I've noticed while I was looking more closely at this plate to find out why this rubbing is it's disc-shaped. I don't know whether it is supposed to be, but it is very, very slightly dished towards the centre, so that when you tighten it up it does actually flatten itself out. But this plate is distorted. Along this edge there was a kink here. Oh, don't know if you can see it now, hang on, fingers, there we go, that's better. There was a kink just there, which I flattened out in the vise. It may have been clobbered, but looking at it, it is distorted. It's quite thin stainless steel. Obviously the shoes themselves need to be ferrous because they magnetise, but this is stainless steel, and you may be able to see perhaps down the edge there, it isn't flat. Now whether this was flat from day one when it came out of the factory, I don't know, but it's definitely dished towards the centre, but along the edges it's not flat. And with a retaining point there and there, if there's a slight bow in there, that's not going to flatten out easily, other than whether these pull it down. And it's certainly not the flattest piece of steel I've ever seen, and that probably explains, certainly definitely the kink that was here, which I've taken out with the vise, probably explains why this shoe here was getting clobbered. Because it's lost a few hundreds of or thousands of a millimetre off of there. But I'm now going to put everything back together, and then I'm going to do a current test on this new coil and just make sure it's actually drawing in it. Well, I want to make sure that we are getting about 25 amps through the turbine. I don't see any reason why we shouldn't. Right, that's it all put together, other than the connector block, which I'm waiting for some new nuts. The existing nuts are clamp the cables to the connector block. They're a bit rusty and grotty, so I just want to get a better contact, so I've ordered some new serrated nuts. Right, now then, hopefully the display on the current clamp's in focus, but that lead is now connected to number 2, which previously was 12 amps. So if I now connect this up to the battery, there we go, 27 amps on this battery, and a very noticeable, it does turn at a slow speed, very noticeable resistance to turning it because of the effect of the magnets. And I need to research these. I assume this, the faster this thing spins, the more the resistance increases. I don't know, but I'll have to look that up. Right, let's disconnect that. 26 amps, bit of a spark, which is what the diodes in the relay box are designed to prevent rather. So next job is to put it back in the van. Fitting this retarder back in the van was a bit of a challenge, or is a bit of a challenge, because I haven't quite finished yet. Right at the very top there, finger, there are 2 eyelets. They're what we'll probably use when it was originally fitted, because they would have just hauled it in through the chassis and bolted it in place. So I've just used a couple of ratchet straps on those eyelets to lift it up about 6 inches, and that was enough to allow me to get my jack underneath it. The piece of plywood there is because the bottom of the retard isn't flat, so I've made a little jig up, and I've also got a bolt going through the centre of the jack and the plywood into a hole that's originally designed for a grease nipple. On this one it's a sealed unit, and there's just a hole there which is a water drainage hole, and that allowed the jack to locate securely and support the weight dead centre, whilst I kept the thing upright using the ratchet strap. But I've run out of room. I've got to get it up about another 2 inches, and that's my jack on full extension. So I have just put a couple of bits of threaded rod, about 8-inch length there, and whatever I could find over there, into the securing bolt holes. Now I could go mad and just do these up and put it right into place, but I'm not. I'm going to drop the jack down now, stick a piece of wood on there and lift it up the last couple of inches. Then I can secure the proper 2 bolts, that one there and the one on the other side, and then take the bits of threaded rod out. That's the theory anyway. 70 odd kilos vertical when you're laying on your back, impossible. And you can see there I've made a cover. That cover was missing for the wiring harness, so I've made a cover up for when I come to wire it up, which may well be tomorrow. Right, let's have a go at getting this jack. So there you go, bingo, done it. Swapped out my little adapter for a 4-inch block of wood. That enabled me to lift it up, put the nuts on the 2 bolts that are already still in place, remove the threaded rods and put the other 2 bolts in. I'm now going to do them up loosely and then take the jack away so it can just settle, because I think it may be slightly pushed over to one side at the moment. I just want to get that lined up as straight as possible, do the bolts up, and then I'm going to fit the drive shafts back on. Now I had originally thought about leaving these rotors off, each one's 12.5 kilograms. It would have been a lot lighter and easier to fit it, but I'm glad I didn't, because I think getting these rotors on to the splines with the drive shafts in the way, probably doable, but they're awkward enough to put on when the thing's laying flat. So I'm glad I've put them on. And it rotates and it doesn't rub, and I'm very, very happy about that. And I will put up a performance curve or a graph showing the amount of energy this thing generates depending on the RPM, because when I'm just turning it by hand with all 3 magnets engaged, it doesn't feel like there's a great deal of resistance there, but the energy increases dramatically the faster this thing's spinning. So I'll put that up now. Right, I won't be filming any more bolting anything in. Next job, wiring. There we go, that's the control box all wired up. I've used new nuts where I had some, but I bought M5 instead of M4 for those three there. But they're only low voltage and I buzzed it out okay. The V terminal, which is tucked away at the back there, that needs to be wired up before you put this earth one on, otherwise you can't get to it. That's the one that provides the output to the light on the dash. These are all wired up using exactly the same colour codes as in the wiring diagram that I got from Was Technical many months ago, which is very convenient. The cable on the right, the thick cable, goes off to the retarder itself, and I've just matched the same colours as it was originally wired up as. So that's the terminal box put together. The only thing I need to do now is seal this gland. This gland doesn't have a rubber compression gland like the one on the other side does. So I've run a brand new earth cable. The one that was here originally, I think I mentioned previously, it had been damaged. It had been, the clip here had been removed, and this had got up to there and it was all damaged all the way along. How it didn't manage to wrap itself around the drive shaft, I don't know. I've used the cable that came with this relay control box. It's a little bit longer than ideal, so it's up there in a cable clamp tucked out of the way, just the slack, and then the earth lead is also strapped up there, and then this boot, cable tie there, just to prevent as much water ingress as possible. So now I shall put the lid on the box, and that's job done as far as this retarder is concerned, until I can go and test it, which, as we're not allowed out, and I've got this sawned at the moment, maybe June. Perhaps we'll be allowed out in June. I don't really want to tax this again for this month, only to use it for a one-off. You know, it's a few quid to save, £20 or whatever it is. So maybe I'll be able to test this in June. Now, that's the end of that exercise. Next exercise. See a little box dangling down there? That's for another video. That's the cover for the motor that operates my step. And I will pick that up in my next video. Thanks for watching.